Next unit, segment in triangles. So the essential question, what are the different segments in a triangle and what is special about them? So just to remind you guys, don't forget a line goes on eternally in both directions, a ray goes eternally in one direction, and a segment or a line segment has two endpoints. Okay, so that's just to remind you of what a segment is. And for our summary, we're going to identify the segment in triangles and their points of concurrency, and that'll hopefully make sense in a bit. All right, the first main idea is perpendicular bisectors. So let's break down that word real quick. Perpendicular, don't forget perpendicular means that a line or a segment intersects another line or segment at 90 degrees. So the way that you can identify this one is by looking for the right angle. And then it says bisector. Don't forget bisector means to cut something in half. Very important. So perpendicular, 90 degrees. And then, bisector half. So you see right here in the figure, we have that this AC has been cut in half as evidenced by, each side being congruent. And then we see that it has a 90-degree angle. So that's a perpendicular bisector. And then it just says here that AF is congruent to FC. So AF and FC are congruent to each other. Oops. And then over here, just kind of touching on that again, the distance from the point E to A and E to C is the same. So it's congruent. So again, the point from E to A and E to C is congruent. You can see right there. And I wrote it down right there. Okay, so the point of concurrency for perpendicular bisectors is called the circumcenter. So let me explain that. So this picture right here, obviously is a triangle. So here's a perpendicular bisector. Here's the second perpendicular bisector and the third one. Now the reason that it has three is because look, triangles have three sides. So this side is intersected at 90 degrees. This side is intersected in the middle at 90 degrees. And this side is intersected in the middle at 90 degrees. And all of those lines come together at one point. And we call that a point of concurrency or a point of intersection. So that point is called the circumcenter. Okay, so some things you need to know about the circumcenter is it is actually the same distance from all three vertices. So all three corners of the triangle are the same distance from the circumcenter, which means that the circumcenter is said to be a circle, the center of a circle that goes through all three vertices of the triangle, as you can see here. Okay. Median. So this is our next type of segment. So our first type of segment was, again, the perpendicular bisector. Now the second type of segment is called a median. A segment that connects a vertex of a triangle to the midpoint of the other side, of the side opposite to it. So what that means is basically a median starts at a vertex or a corner, and it's just going to go to the middle of the opposite side. And we know it's at the middle because of these two markings. If you see those two markings, it's equal on both sides, which means, it hit the middle. All right, so that's what the median is. Something really important to note about medians is that medians and centroids, rather. So if BF is a median and Y is a centroid, right? The distance from Y to F is 1/3 of the entire median. And then from B to Y is, 2/3 of the entire median. Okay, and then of course the whole median would just be a whole, or 3 out of 3. Okay, so we'll talk about that a little bit more in detail later. All right, and again, the point of concurrency, so the point where all the medians come together, is called the centroid. So we see that we have a median here, a median here, and a median here. And they all meet at this point, and this point is called the centroid. So when you see these markings on a triangle, you know that it's talking about medians. So it'll be a median problem. Okay, so now we have angle bisector. So this is the third type of segment in triangles. So an angle bisector is a line, segment, or ray that cuts an angle in half. All right, so boom. So you got A, B, C. That's the angle up at the top there. That's the vertex at the top. And you can see that BG cuts that angle in half. How can you tell? Look for those little arcs. Remember, those arcs mean that they're congruent. And if it's congruent on both sides, that you can say it was cut in half. So angle ABG is congruent to angle GBC. So ABG and GBC are congruent to each other. All right, so that's what an angle bisector is. Now let's talk about kind of some things that you need to know. So let's just say BG again is the angle bisector. Let's say point Z is on that angle bisector. If we go straight to the sides here at a right angle, those distances are congruent. So JZ and ZK are equal. They have equal distances or equal lengths. All right. So let's talk about the point of concurrency or the point of intersection for these three angle bisectors. So we got this angle bisector, it cuts that angle in half. This bisector cuts angle A in half. This cuts angle C in half, and they all meet at one point, and that point is called the incenter. So this point of concurrency for your angle bisectors is called the incenter. Okay, so incenter also creates a circle, but this circle is going to be inside. So the other one, the circumcenter, that circumscribed the whole triangle. The incenter is a circle inside the triangle. And as you can see here, these distances are all congruent. Got that, and that. They're all three congruent. Okay, now this is the fourth and final segment. So altitude, you already know what this is. This is the height of a triangle. It's just a fancy word for height. A segment that connects a vertex of a triangle to the side opposite to it at a 90-degree or right angle. So over here you can see you start at the vertex or the corner, and then you just go straight to the other side at a 90-degree angle. That's an altitude. That's a height. That's how you do height of a triangle. Okay, so now we see over here we have one altitude, two altitudes, and of course 3 altitudes, and they all come together at one point. That point, or the point of concurrency, is called the orthocenter. So the orthocenter is the point of concurrency for altitudes. Okay, so those are the 4 types of lines of concurrency. And those are the 4 segments and their lines of concurrency, points of concurrency, Lord have mercy. All right, name the point of concurrency for every figure. So now we got some examples. So don't forget, for altitudes, that would be the orthocenter. This is just vocabulary. You have to remember that orthocenter and altitudes go together. So the altitude is the line, the orthocenter is the point where the lines connect or come together. All right, now here we have perpendicular bisector. Don't forget, this upside down T means perpendicular. So perpendicular bisectors, the point of concurrency for those is the circumcenter. Okay, so that's the circumcenter. So that is the circumcenter, just like this is the orthocenter. Okay, now for medians, and again, I know these are medians because of these markings telling me that these lines are breaking or are cutting the sides in half. So for medians, that would be the centroid. Okay, so this point right here is called the centroid. And then over here we have angle bisectors. This symbol right here, I'm gonna put a little arc through it. I'm gonna call that the symbol for angles. So these are angle bisectors. You can tell because you see the angles are marked. Okay, boom, that's congruent to that. Okay, so all the angles are cut in half. Anyway, so the point of concurrency for angle bisectors is called the incenter. We just went over that, and now we just had those 4 examples.